Santa Ana winds are dry, usually warm, often very powerful winds blowing offshore in the Southern California region. Even if you live in the Los Angeles basin, it's possible that you have not experienced the power of Santa Ana winds. However, if you live near one of the passes that are affected by Santa Ana winds, you are very aware of the speed and the power of these winds that can blow 40 miles an hour and have gusts that have been recorded at as much as 100 miles per hour. To understand Santa Ana conditions, we need to first understand normal conditions in Southern California. Typically, we're dominated by high pressure. The cold ocean water creates that high pressure cell. And the relatively warmer surfaces of the deserts create low pressure. Air always moves from high to low pressure, creating that usual onshore flow. During Santa Ana conditions, the winds reverse. Now there will be an offshore flow. If there is now an offshore flow, that means that the high and the low must have switched locations. Where there once was a low, now there is a high, and where there once was a high, there is now a low. Air always moves from high to low pressure, creating the Santa Ana winds. This is a satellite image on a day with Santa Ana winds. Santa Ana winds are often associated with the devastating fires that occur on these days. But this image also clearly demonstrates the offshore flow of the Santa Ana winds. Santa Ana winds can occur at any time of the year. However, they are most common in the fall. And to assist our understanding of Santa Ana winds, we should think of them as occurring in the fall. But why? Why do they mostly occur in the fall? Think about the weather shifts that begin to happen in the fall. And also think about what season follows fall in Southern California. In the fall, it begins to cool down, especially in the deserts. And also for Southern California, winter is our rainy season. In the fall, what's it like in the desert? Doesn't it begin to cool down? Maybe you and your family go camping or dirt bike riding. When do you go? You go in the fall, and it is cold, especially at night. That cold land creates the high pressure. And in Southern California, with winter approaching, we know that our Hawaiian high is going to weaken. That weakened Hawaiian high creates a space for relatively low pressure compared to the inland high that has formed. This creates the Santa Ana winds. One more time, how does this oscillation of pressure occur? The Great Basin and Mojave Desert begins to cool in the fall, which creates a high inland. And with winter approaching, our Hawaiian high is starting to weaken. We know it's going to weaken because the Aleutian low that brings us rainy conditions will be moving its way into Southern California. Have you noticed how hot it can be on a Santa Ana wind day? These winds might show up on a November day, the day before I'm wearing a sweater, and Santa Ana winds arrive, and it is hot in Southern California. Why are Santa Ana winds warm? Think about where these winds are coming from. They start at a higher altitude. In the Great Basin and Mojave Desert, they start at 4,000 feet in elevation and descend down to sea level. Remember that 5-star rule? When gas is compressed, its temperature increases. As the air descends, it is adiabatically warming. It is warming solely because of a pressure change. Because the air mass is dry, it will warm based on the dry adiabatic lapse rate of plus or minus 5.5 degrees for every 1,000 feet of elevation. In this case, because the air mass is descending and sinking, it would increase 5.5 degrees Fahrenheit for every 1,000 feet. Let's look at an example. If it is 70 degrees in the Great Basin at 4,000 feet, it will be 75.5 at 3,000 feet. Continue to increase 5.5 degrees for every 1,000 feet, making it 81 at 2,000 feet, 86.5 degrees Fahrenheit at 1,000 feet, and 92 degrees in November at sea level, making it a hot and windy day.